Hello there, and welcome to this video on solving problems using systems. So in previous videos we've looked at solving problems graphically, so that is going to be here on the left, as well as algebraically, and we looked at two different methods. We looked at a substitution method and an elimination method. So it says systems can be solved graphically. This is going to be our first way, and graphically means either using a calculator or you can sketch it on a graph. And you're going to use this when you wish to see how the two variables relate. So maybe how like the distance relates to the time, or how cost relates to time, something like that. And also it says such as for cost analysis, so anything to do with kind of like money. And it says for speed problems. The other way that we can solve these is algebraically, and our two methods we said were substitution or elimination. And you're going to use this when you only need the solution, so you just need the answer, which will be at the intersection point, or it is unclear where to locate the solution on a coordinate plane. So if you were doing it graphically and you don't know where it's going to be on the graph, it might be better to just do it algebraically. So we're going to have two examples that we're going to look at. Our first one here, it says Sam rented a car from the same company twice last month. The cost of the first rental was $116.70 for 3 days, and she drove 98 kilometers. The cost of the second rental was $78.80 for 2 days, and she drove 72 kilometers. So part A, it asks us to create a system of equations. Now you might not know this, but when you rent a car, normally what they're going to do is they're going to charge you for the number of days that you use it, and also they'll charge you for the number of kilometers that you put on the vehicle, because you're going to be wearing the vehicle down a little bit. So what we're going to do first is come up with kind of the idea of how to come up with the equation. So we know the total cost that it's going to be. It's going to be dependent on the number of days that you use it, and it also depends on how much you drove. So our formula is going to be this right here. So our total cost is going to be equal to the charge per kilometer. We don't know what that is, so that's going to be an x for us. We're going to have to figure out what that is. So we'll take the charge per kilometer and you'll multiply that by however many kilometers you drove, and we're going to know that. We're given that up here. Plus our daily cost, however much it costs per day. Maybe it's $30, $40, we don't know. But we'll times that by however many days we had it. And that is given to us up here. So our first rental is going to give us our first equation. So our total cost for that one was $116.70. I'm just going to put that here, $116.70 equals, and then I'm going to have my charge per kilometer, which is x. I don't know what that is, so it's going to be x times the number of kilometers. So for that one it is 98 kilometers, so I'm going to go x times 98. But rather than writing x times 98, what I could do instead is I could just say that is 98x. Then we had a plus sign that was right here, and then our daily cost, we didn't know what that was, so we're going to put the variable y for that one. So it's going to be y times the number of days, and for that one we did 3 days. So this is going to be multiplied by 3, and again, rather than going y times 3, what I'm going to do is I'm just going to say that is equal to 3y. So that is our first equation. Our second equation is going to be quite similar to that. So for that one, the total price was $78.80. So I'm going to put $78.80 is going to be equal to, and then we had 72 kilometers. So it's going to be 72 times the price of a kilometer plus, and then we have this part. So that was our daily cost, y, times the number of days. And we went 2 days. So it's going to be 2 times y. Now with these equations, these ones are dealing with money, okay, and we have decimals, so it's going to make it more difficult. So if we looked up here, when we had something dealing with cost analysis with money, we're going to want to do this graphically. So we'll go back down here. Now in order to do it graphically, in that lesson what we did was we always had to get it into y equals. So I'm going to convert this into y equals. So to get this y by itself, I'm going to first subtract 98x from both sides. And then these ones are going to cancel. So what we get is just a 3y on the right, and then on the left we have negative 98x plus 116.70. And now we still got to get rid of that 3, so we're going to have to divide by 3 divide by 3, divide by 3. And then these 3's will cancel. So the only thing we have left is a y. Now I'm going to write that just over on this side. So we got y on that side. And then these fractions, those numbers aren't divisible by 3. So we're just going to leave them as they are. So we're going to have negative 98x over 3 plus 116.70 divided by 3. So next we're going to do the same thing for this equation. So I'm going to first get rid of this 72x by subtracting 72x from both sides. They'll cancel on that side. So on the right we only have 2y, and then on the left we have negative 72x plus 7880. And then we got to get rid of this 2 in front of the y, so we'll divide everything by 2. So those 2's are going to cancel. And then I'll only be left with a y, and again I'm going to write it on the left side, so I have y equals, and then these ones over here on the left, I'm just going to keep them as they are, but I'll just write them on the other side. So it's going to be negative 72x divided by 2 plus 7880 divided by 2. If you wanted to divide them, you could, but you wouldn't have to. So next what we're going to do to solve this, we said we were going to solve it graphically, so we're going to use our calculator. So you can get out your calculator, and then you can go to y equals, and then we can type this one in. Just make sure for this is a negative, leading negative. You have to click the negative button, and then the rest I'll just type in. So we've got that one in. Then we can put in our second one. Again, it's got a leading negative, so make sure you click negative and then type in the rest. Okay, and then once we've got that, we can click graph. And these bars mean it's graphing. So we got our 1 coming down, we got one line, and we don't get a super good picture. So what you can try doing is click zoom, and then option number 0, it should say zoom fit. So right here, for your calculator, it might be a little different. For me, it's at 0. So it regraphs it, it tries to fit it as best it can. So we got our one line, and then we got our other line coming down, and we can see they cross somewhere in here. So to find that crossing point, we click second, trace. That's option number 5, intersect. Next, as long as we only have those 2 lines put in there, we can just click enter, enter, enter. And then we'll get our solution. So we have x is 0.15 and y is 34. So I'm just going to write that down. So we know what x and what y is, and we had written what those were up top here. We had that x was the charge per kilometer and y is our daily cost. So that's going to help us be able to answer these next 2 questions. For part B, it says what is the daily rental cost? So that was what we had as y. So if it's 34, that's going to be $34. So that's our answer for B. And then for part C, what is the charge per kilometer? Well, we said this was our charge per kilometer. We had that up here. It was x. So our charge per kilometer is 15 cents, or 0.15 of a dollar. And then lastly, part D, it says what method did you use to solve the problem and why? And we had used our graphic method, and that was because with this one, we wanted to see how the relations related, and we also did it because it dealt with money. So I got there, we used the graphical method because you can see how the equations relate. And also, with this one, we're going to have decimals and fractions and whatnot. If we use our calculator, it is going to make it the easiest. So we got one more example that we're going to do, number 2 here. It says, yesterday Ethan read a 220-page book. Before dinner, he read at a speed of 50 pages per hour. At bedtime, he read at a rate of 41 pages per hour and finished the book. So he's read the entire book, and he read at 2 different rates. He read at 50 pages per hour, and then later he read at 41 pages per hour. And then lastly, it says he spent a total of 5 hours reading the book. So we're asked, how much time did he spend reading before dinner? So that was during this 50 pages per hour time. And we're going to express our answer in the nearest hours and minutes. So in this question, we know how quickly he's reading before dinner and after dinner, but we don't know how much time he's reading. So what we're going to do is we're going to label those as our variables. So we're going to say x equals the number of hours before dinner, and y is going to equal the number of hours after dinner. So if he reads at 50 pages per hour before dinner, we're going to have to take 50 and times that by however many hours he read before dinner, plus he also read at 41 pages per hour after dinner, but we don't know how many hours that was, so we're going to have to multiply by the number of hours, which is y. And when we add up all of those pages that he's read, it said he read the entire book, which was 220 pages. So it's going to add up to 220 pages. So that's one equation that we've got. The second equation that we're going to have to get is going to come from this last sentence right here. It says he spent a total of 5 hours reading. So the number of hours before dinner and the number of hours after dinner, when I add those up, I have to get 5 total hours. So the number of hours before dinner plus the number of hours after dinner, that has to add up to 5 total hours. So with this system, these two equations, it has nothing to do with money or speed. So we're not going to solve this graphically. For this one, we're going to do it algebraically. And I'm going to solve this one using substitution. So what we want to do first is we want to convert one of these into y equals or x equals. Now I'm picking the second one here because it's much simpler than this one. So I'm going to rearrange this one. I'm going to rearrange it into x equals. You could also use y equals. I'm just going to use x equals. So to do that, I'd have to move the y over to this other side, and when something moves over to the other side of the equation, it's going to change sign. So I'm going to have x equals, and then there was a 5 over there, and then when the y comes over, it's minus y. So now I kind of have 3 different equations. I'm going to label this one equation 1, this one's like our equation 2, and then this one's like our new one, equation 3. So we're going to take equation 3 and we're going to have to substitute that into equation 1. So I'm just going to write that down. So equation 1 was originally 50x plus 41y equals 220, but now x is going to change into 5 minus y. So this is going to be 50 times x, which is actually now 5 minus y. And then we had plus 41y, and that equals 220. So to solve this, first what we're going to do, whenever you have brackets, distribute in to get rid of the brackets. So I'm going to have 50 times 5, that's going to be 250. And then I'm going to have 50 times negative y, that is negative 50y. And then plus 41y equals 220. So these are both y's. I can put those together. So I'm going to have 250 and then minus 50y plus 41y, that is negative 9y, then equals 220. And we want to get this y by itself, so we're going to have to subtract off this 250, subtract off 250, and then 250s will cancel on the left. So we have negative 9y equals, and then 220 minus 250, that's going to be negative 30. And then lastly, let's get rid of that negative 9. We just divide by negative 9 on both sides. The negative 9s will cancel out. And we get y is equal to, these negatives here will also cancel out. So I got 30 over 9. And as a fraction, that is 3.3 repeating. So we have y is equal to 3.3 repeating. Now y, we had said up top here, is the number of hours after dinner. Okay, and it said how much time did he spend reading before dinner. So what I'll do is I'll convert the time that we just got into hours and minutes, and then after I'll be able to know how much time he spent before dinner. So 3.3 repeating is really like 3 plus 0.3 repeating. So this is going to be 3 hours plus 0.3 hours, and then to change this part into minutes, what you can do is multiply this by 60. So it's going to be 3 hours, and then if you take 0.3 repeating and you times by 60, you're going to get 20. So this is going to be 20 minutes. So if you read for 3 hours and 20 minutes after dinner, that means the remaining time is for before dinner. So the remaining time is going to be 1 hour and 40 minutes. So I'm going to say, therefore, x, which is the time before dinner, is going to be 1 hour and 40 minutes. And the reason I knew that this was going to be 1 hour and 40 minutes, picture you're starting at 3 hours and 20 minutes. You need to get up to 5. So to get to another full hour, you'd have to add on 40 minutes. So that'd be 40 minutes. And then you'd be at 4 complete hours. And then you still need 1 more hour. So there's your other hour. So that was the last question that we were going to look at. Our homework questions are on page 498.